Okay. Yeah, yeah, yeah. Yeah, I have pointed that out. Uh, so while solving the C00, I think the whole term will be zero. So that will not affect in the calculation of C00, but in the calculation of C11. Yeah, yeah. So at the end, I think after some time, I have calculated it to 1, to n. Yeah, yeah. There is a two. Yeah, yeah. We have to calculate using 2n only. In the video, you will see that after in C00, I didn't consider, but the whole term will be zero, so that will not affect in But yeah, Yeah, hello everyone. Let's start the session. I hope I am audible and visible. Very good evening and warm welcome to all of you. This is a week 7 live interactive session of signal processing techniques and its applications. My name is Pooja Verma. I am PMRF Research Scholar from IIT Kharagpur and instructor for this course is Professor Syamal Das Mandal, Advanced Technology Development Center, IIT Kharagpur. For this session, first we will go through some concept and formulas, then we will solve some assignment questions, which is very similar to your assignment problems. Okay, so let us start this week content. I hope all of you gone through this week content. So the content for this week is fast Fourier transform algorithm. So fast Fourier transform algorithm is basically a time domain signal to convert DFT efficiently. So this is an algorithm. This is not a unique algorithm. There are so many algorithms available for solving the DFT problems. So as we know that for computation of DFT, we require n square complex multiplications and n minus 1 complex additions and consequently 4n square real multiplications and 4n n minus 1 real additions. So direct computation of DFT is basically inefficient. So because it does not exploit the symmetricity and periodicity properties. So as already we have know that we have gone through this formula. So here we will see the one algorithm to solve the problem of DFT, that is divide and conquer approach. So how to solve or how to go through this concept we will see in this slide. So as we know that x of k is equal to n belongs to 0 to n minus 1 x of n w n k n, where w of n e to the is equal to e to the power minus j 2 pi by n. Here sequence x of n, let n is the total number of samples. So in the divide and conquer approach, the total number of samples must be taken in this, so that L into M. So the multiplication of L and M must be equal to the total number of samples. So here the total number of samples dividing into different samples. So x of n can be stored in either one-dimensional array index or in a two-dimensional array indexed by L and M, where L varies from 0 to L minus 1 and M varies from 0 to capital M minus 1, where L is the row index and M is the column index. And the mapping of these rows and columns can be done by two ways. The first one is n is equal to ml plus m, and that is the mapping in the row wise, and the second one is a mapping through the column wise, where n is equal to l plus capital L and m. Okay, so if x of n is mapped into the rectangular array x l comma m, and xk is mapped into corresponding rectangular array xp comma q, then mapping can be performed either k is equal to capital mp plus q or capital p plus q l capital L. So here two-dimensional array of this mapped signal can be represented as x p comma q is equal to summation of m is equal to 0 to m minus capital M minus 1, and the summation L varies from 0 to capital L minus 1, x m L w n L plus capital L m multiplication with capital M p plus q. So complexity related to this divide and conquer approach will be the total number of multiplications will require to compute uh, this equation will be the ml in multiplication in brackets m plus l plus 1, and total number of additions required, that is lm in brackets m plus l minus of n. Okay. So algorithm to solve this divide and conquer approach, what are the different uh, ways to store or locate the samples? So divide and conquer approach is a matrix or array related like this, where we know that M is the number of rows and L is the number of columns, capital M and capital L. So total number of columns will be the M minus 1, that is L minus 1. It can be interchange, it can be the interchange, depends on which mapping you will choose, either row wise or column wise. Okay. So for our first algorithm, so store the signal first column wise. So first we will store the signal into the column wise, first column, second column, then compute the M point DFT of each row. Then we will compute the M point DFT of each row. Okay, then multiply the resulting array by a phase factor W, that is WNKN. Okay, then compute the L point DFT to each column, then compute the each the columns L point TFT. Then read the resulting array, then row wise. Okay, the second algorithm to solve the divide and conquer approach is store the signal first row wise. First we will store the signal row wise, then compute the L point DFT of each column, then multiply the resulting with by the phase factor W, then compute the M point DFT of each row. Then we will compute the M point DFT of each row. Then read the resulting array in column wise. Okay, these are the two algorithms to store the signal or to compute the DFT using divide and conquer approach. So the second algorithm is radix to FFT algorithm. So what is a radix to FFT algorithm? So let we have n number of samples, total n number of data points, and n must be 2 to the power v, where 2 is the radix. That's why this is called the radix 2 algorithm, or v is the number of stages from which we will divide. Let's see, this is a 8 point DFT. If there is a 8 point DFT, so we will write it out to the power 3, where 3 denotes the number of stages. Okay, we will see it. So there are also two ways to compute the DFT. First one is decimating in time, and second decimation in frequency. So first we will see we will see the decimating in time algorithm. So first split the n point sequence into two n by 2 point data sequence, that is called f1 n and f2 n, and corresponding the even number and odd number of samples. So f1n will be the even number of samples and f2n will be the odd number of samples. And f1n and f2n are obtained by decimating x of n by a factor of 2, and hence the resulting FFT algorithm is called decimating in time algorithm. So total number of complex multiplication required to compute the radix to FFT is n by 2 log base to n, and total number of complex additions that is required to compute the radix to FFT algorithm is n log base to n. Okay, so we will solve these radix to FFT algorithm using butterfly computation or butterfly diagram. This is called the butterfly diagrams, the cross one. So while we are decimating in time, so here the input signal we will take. So input signal we will take in reversing bit reversing order. This is called bit reversal. Okay, this side. So my pen is not working, so that is So the input signal from this side where it is written dual node spacing. Okay, this side x0, x4, x2, s6. This is the bit reversing order. Okay, and this butterfly diagram, first it is looking like this. This is a three-stage butterfly diagram, and in the input signal we will given the bit reversing order, and at the output end we will get the exact signal, the DFT of the exact sequence. Okay, so in the butterfly diagram, in the first we will make a butterfly of two rows each, then we will increase the butter groups. Okay, like this, and multiply the phase factor in this. And in the decimating in frequency, so another one is decimation in frequency. So in the decimation in frequency, here the input is directly given. Whatever signal is given, x of n or x of k, it is directly written to the input, and opposite in with reversing order we will get the output. Okay, so it is also depend on number to the power v, depends on that we will compute the number of stages. So whatever in the decimation in frequency time, then the exact opposite to the we will do in the decimation in frequency. Okay, so these are the some concepts which are applicable to our questions. So let's move to the questions. So this is the assignment 7 questions. So the first question is, which of the following is true regarding the number of computations required to compute n-point DFT? So already we know that the n-point DFT, what are the complex multiplications and complex additions required to compute the n-point DFT. So option A is n square complex multiplications and n minus 1 complex additions required. Option B is n square complex additions and n minus 1 complex multiplications required. Option C is n square complex multiplications and n plus 1 complex additions are required. And option D is n square complex additions and n plus 1 complex multiplications required. So as we know that what is a n-point DFT formula, x of k is equal to summation n is equal to 0 to n minus 1 x of n w n k n, where w n is equal to e to the power minus j 2 pi by n, right? So the total number of complex multiplications are required. So here we need to compute the n-point DFT. So total here the n number of multiplications are required here, and n number of multiplication of these two required, and for computing n-point DFT, so multiplied by n. So a total n square complex multiplications are required, and there is a n-point DFT. So n and what are n minus 1 complex, these multiplication then addition, multiplication then addition. So n minus 1 number of complex additions required. Okay, so compute the n-point DFT total n square complex multiplications and n minus 1 complex additions required. So option A is the correct answer. Okay, so moving to the next question. Let The second question is, n is equal to 88 point DFT is computed of a sequence x of n using divide and conquer approach, where n is equal to m cross l and m is equal to 8 and L is equal to 11 is given. For computation, the sequence is stored in a two-dimensional array indexed by m and L. If mapping is done, n is equal to ml plus m, then how many rows and columns will be in the above two-dimensional array? So here given n is equal to m into L, and we know that also. Here m is already given, m is equal to 8 and L is equal to 11. Mapping is done by n is equal to m, capital M, L plus m. So how many rows and columns will be there? So as we know that this is a two-dimensional array. There are so many number of, as we know that L is the row index and M is the column index, right? And L varies 0 to L minus 1 and M varies 0 to M minus 1. So the L is the row index, so row vary, L is given, so 0 to L minus 1 is 10 and M is equal to, M is the column index, varies to 7. So how many rows and columns will be there for this? Here L is the row index, so L varies, L is 11, so 11 rows and 8 columns. Okay, have you got this question? So option A is the correct answer, that is 11 row and 8 columns. Okay, it depends on mapping is done which way. There are two ways of mapping, already told in the previous slides. Okay, so next question, n point DFT is computed of a sequence x of n using divide and conquer approach. Yeah. Then that mapping is done by, let's say there is a m plus ll, right, or ml. So then exact what number of rows will be 8 and number of columns will be 11. It depends the mapping which will be done, in which way we will be done. Okay. So n point DFT, next question is n point DFT is computed of a sequence x of n using divide and conquer approach. During the computation, if sequence x of n is stored in row wise, then DFT output will be stored in option A is row wise, option B is column wise, and option C is row and column both. So already we have seen in the previous slides the algorithm and 1 and 2. So if a sequence x of n is stored in row wise, then DFT must be computed by, column wise, right? So in the algorithm 1 and 2, we have seen that if the DFT of a sequence x of n is stored in row wise, then DFT of that output will be stored in the column wise. So the correct option is B. The DFT will be stored column wise. Okay. Okay. Moving to the next question. N point DFT is computed of a sequence x of n using divide and conquer approach if the value of n is equal to 40 multiplied by 25. Determine the number of complex multiplications. So as we know that n is equal to m into L. So here M is equal to 40 and L is equal to 25. So here they have asked for complex total number of complex multiplication. How many complex multiplications are required? So as we know that total number of complex multiplications are required from the formula ML, M plus L plus 1. Just M plus L plus 1. Complex multiplication required. Total number of complex multiplication required. So M and L is given 40 multiplied by 25 in brackets 40 plus 25 plus 1. So 40 multiplied by 25 plus 40 plus 25 plus 1. So 6 plus 6, 66. That will come 40 multiplied by 25 and 66, 66,000. So already I have instructed that please carry one calculator in order to compute that numbers. So if you multiply 40 into 25 and plus 66, you will get 66,000. So the correct option is A. Okay. So total number of complex multiplications are required to compute that n point is 66,000. Okay. I hope you understand this question. So we can move to the next question. Okay, so the next question is DFT of a signal x of n is computed using radix to FFT algorithm. If the length of the DFT is 1024, how many butterfly computation process will be required? So this is using radix to FFT algorithm. DFT is computed and the length of the DFT is 1024. That is n is equal to 1024. So how many butterfly computation process will be required? So number of butterfly computation required, number of butterfly computation required for radix to FFT algorithm. So FFT is n by 2, capital N by 2 into n, small n. So what is a small n? So we know that n is equal to 2 to the power v. V is nothing but n, or you can write it to the power n. So what is it? Is 1024. So if we will write it to the power 10, then it will come to 1024. So here n is equal to 10, and n, capital N already is given 1024 divided by 2 multiplied by 10. So that will come 5, 1, 2, and if you multiply by 10, so 5, 1, 2, 0. So total number of butterfly computation required for radix to FFT algorithm is 5120. So correct option is A. Right? Okay. Have you understand this question? So we can move to the next question. So the next question is for computing 5 12 point DFT using destination in time radix to FFT algorithm determine the required number of complex additions. So here n is given, that is 512, 512, and decimating in time radix to FFT algorithm. So total number of complex additions required, as we know that complex addition required to computing radix to FFT algorithm n log base to n, right? This is given in the previous slide. This is a formula for computing n-point complex addition using radix to FFT algorithm. So n is given, that is 512 log base to 512. So 512 can be written as 2 to the power 9, right? 2 to the power 9 is equal to 512. So this is a log base to 2 to the power 9. So if you solve this, it will come 9 multiplied by 512. If you multiply 9 by 512, the result will become 4608. You can multiply in your calculator. Okay, this is a 9. So the correct option will be the D. Okay, have you got this question? I hope all of you get it. So can we move to the next question? Okay. So moving to the next question. Which is the correct order of the following steps to be done in the algorithm of divide and conquer approach? Which of the four is the following the correct order? Okay, so first is store the signal row wise, compute m point DFT of each row, compute the L point DFT of at each column, multiply the resulting array by the factor W or phase factor, read the resulting array column wise. So any one of you want to answer this question? Already in the previous slide, we have gone through the algorithm 1 and 2. So what is the correct approach or correct order to solve in the divide and conquer approach to solve the problem? So as we know that if we store the signal row wise, then compute the m point DFT of each row, then multiply by the phase factor, then compute L point DFT at each column, then read the resulting array in the column wise. So if we store the signal row wise, then we will compute the resulting array by column wise. And if we store the signal column wise, then we store the signal row wise. Okay, please remember these 2 points. So the correct option is 1 to 4th, then 3rd, then 5th. Okay, so the correct option is B. Just remember this one. If you are storing the signal row wise, then computing each m point DFT each row, then multiplied by phase factor, then compute L point DFT, the DFT of each column, then the resulting array we will read by column wise. Okay. 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 Moving to the next question then. If we split the n point data sequence into two n by 2 point data sequence f1 and f2n, and corresponding to the even numbered and odd numbered samples of xn, and f1k and f2k are the n by 2 point DFTs of f1n and f2n respectively, then what is the first n by 2 point DFT of xk of xn? Option A is f1k plus f2k. Option B is f1k minus wnk f2k. Option C is f1k plus wnk f2k. So as we know that we have a sequence x of n, it is divided into the even number and odd numbers, that is f1k, f1n and f2n, and their DFT is f1k and f2k, right? If we are dividing the xn, then what are the even and odd signals or odd samples? The even number of samples, as we know, that is noted as f1n, that is x of 2n, and f2n is the odd number sequence, then it is represented as 2n plus 1, right? And as we know that what is a DFT of an n point sequence, that is n varies from 0 to n minus 1, that is n minus 1 x of n x of n w n k and n. Okay, so here xn is divided in x to n plus x to n plus 1, and number of samples also divided n by 2. So here n will vary, n is equal to 0 to n by 2 minus 1, even number of samples, that is x to n, and multiplied by the phase factor. Here 2kn will be there, 2kn plus odd number of factors, that is n varies from 0 to n minus n by 2 minus 1, x to n plus 1. So just a minute. After that I am writing here, that is n is equal to 0 to n by 2 minus 1 x to n wn 2kn plus n varies from 0 to n by 2 minus 1 x to n plus 1 and multiplied by the phase factor. wn k to n plus 1. Okay, so from here n is equal to 0 to n minus 1. Already we know that the event sequence DFT is represented as f1k, right? That is x to n. So it can be written as f1 that small one f1n here, and w belongs to n by 2. If we will take the n but this 2 in the denominator, then it will come like this, right? Similarly, m is equal to 0 to that n by 2 minus 1, and f2m will be the odd number of sequences. Here we will do it. And similarly, n by 2 will be take it this side, then it will, if we multiply the inside the, then it will be the kn. 2 will be this side, and plus w n k is the other phase factor here, kn. And here from to right. So what is this? This part, first one is f1 n w n by 2 kn for n by 2 point ft. This is represented by f1k, right? Then multiplied by plus this phase factor wnk with f2k, right? This is the extra phase factor that is represented 2n plus 1, that 2 is also n by 2, so this is a odd sequence represented f2k, so that f2k is multiplied by this phase factor, right? So what is the correct option for this question? Is option C, f1k plus this phase factor wnk plus multiplied by f2k, right? Have you got this question? Sorry, something, there is a hotspot is going on, so my pen is stopped working in between. I don't know what is the problem. So have you got this question or understand, or I can repeat this one? Anyone can answer. Have you got this one? Okay, thank you. Okay, so moving to the next question. So the next question is, if xk is the n by 2 point DFT of the sequence x of n, where n is 256, then what is the value of xk plus 128, where f1k and f2k are the n by 2 point DFT of f1n and f2n respectively? And as we know, the f1n and f2n is corresponding the even numbered and odd numbered samples of x1, x of n, right? So as we know that x of n is a one sequence which is divided even number of samples and odd number of samples. That samples are f1n and f2n and f2n, and their DFT representation is capital F of 1k and f of 2k. And f1n also represented as f of 2m or 2n. This is the even number of samples sequences, and f2n is the odd number of sequence. It can be represented to n plus 1, right? And DFT of this one is f2k, and for even sequence f1k, right? Already that we know that. We have solved the previous question based on that, but there is a number is given, we will solve it here again. Okay, so what is the value of xk plus 28? So that 256 is divided, there is the n is 256, so 256, so n by 2 will be 128. So what will be the upper k plus 128 value? Okay. So already we have solved that x of k is equal to f1k plus w n k f2k, and also we know that f1k and f2k are aperiodic with n by 2. So f1 is k plus n by 2. So f1k and f2k are follow the periodicity property. K plus n by 2 is equal to f2k, right? But in the f2k there is a phase factor, right? That wnk. So if we apply the periodicity property in f2k, then it will also be add in this phase factor. So w n, the periodicity of f2k is the same. So here we need to add n by 2 f2k in the odd periodic sequence, that order sequence. So I'm writing after this here. So what will be the value we will get? From here wn k, if we write it and multiplied by wn n by 2, if we difference, if we do the calculation of this factor, and this will be multiplied by f2k, right? All those. So I'm not writing again, I will write it in the last now. So what will be the value of this? wn k wn n by 2. What we will get the value of this? If you solve this, then wn by 2, then it will come to n, right here, if you take this one. So w of 2, what will be the value is, that will come -1 if you solve this. E to the power minus j 2 pi n, then 2 pi to 2, and that n is 2 here, so there will be 2, so e to the power minus j pi will be the -1, right? So this factor is multiplied by this, that will be the -1. Then here we will get n f2k, right? So what we will get? f2n plus 128, then just we will put here in this term 128. So the n, the value of n, so correct option will be the f1k minus w256k f2k, right? Because this part will be the -1. So at the end we will get f1k minus wn k f2k. If we put this value in this, then we will get f1 k w256k F2 K, right? F1K minus W2 56K F2K. So the correct option is B, right? For this question. Have you got this question? Have you understand? Okay, I hope all of you got this question. So we can move to the next question. Okay, so the next question is the butterfly diagram as given in figure 1 is used in the computation of. So first we will need to see this the what is a input order and what is a output order. Then we will try this is a x0 x of 0 0 1 2 3 4 5 6 7. So here the input is given as a sequence x of n is given, but output is in the bit reversing order as we see that, and there are 8 number of points 0 to 7, so that means n is equal to 8, right? So it must be 8 point DFT, and now we need to see input is in the real sequence and output is in the bit reversing order. So this is a DIF, that is decimating in frequency domain, radix to FFT algorithm. 8 point decimating in frequency FFT algorithm. So let's see what are the correct, what are the options are there and which one is correct. So option A is 8 point DFT of decimating in time radix to FFT algorithm. So this 8 point but decimating in frequency. So option B is 8 point DFT of decimation in frequency radix to FFT algorithm. So option B is the correct option. It is 8 point DFT and decimating in frequency, right? So if there is somewhere it is given like this butterfly diagram, so you need to check the input order and output order and number of rows, that is number of points are given. So whatever number of points, that is a 8 n point, that belongs to number of samples, and then we will see the input and output order. Then we will decide whether it is a decimating in time or decimation in frequency. Okay, so option B is the correct option for this question. Okay, so moving to the next question. For a decimation in time FFT algorithm, which of the following is true? Option A is both the input and output are in order. Option B, both input and output are bit reverse. Input is bit reverse and output is in order. Option D is input is order and output is in the bit reverse. So it is a decimation in time. So in the decimation in time, we have seen that the input sequence is given in bit reversing order, right? X of n is bit reversal, but output is in sequence. Output is given in sequence. It is a 4 rows are there, so it is a 4 point here, and just for understanding I am making. Okay, so in the decimation in time, the input is bit reverse and output is in the order. So we see in the option C is the correct option for decimation in time FFT algorithm, which of the following is true. So option C is the true. Input is bit reverse and output is in the order, right? Okay. Can we move to the next question? Okay, moving to the next question. So the next question is a designer has available a number of 8-point FFT chips. So explicitly how he should interact 3 such pins in order to compute 24-point DFT. Here n is given 24 point. So there this is a solving question and there is no option. So already solution I have given here. I will make you understand. this question. Okay. So a designer has available a number of 8-point FFT chips. Designer has only a 8-point FFT chips. That means he has only 8-point FFT chips. But it should be connected three such chips that to compute in order to compute 24-point DFT, that 8.3 chips must be added to get a 24-point DFT. So in that 24-point DFT, how we are going to make that 8-point DFT so that we can add these chips to make a 24-point DFT. So first we need to create a three sequences of 8-point each because we have only 8-point FFT chips. So first, what we are doing in FFT algorithm, as we know that input is reversing order. So there are 8 points. So we are just dividing in that even and odd sequences. But here the 3 points are given, 8 points. So first we need to convert in the 8, 8 and what we need to do? We must be take n is equal to in the 3 8-point FTs. So how we will choose first? First we will choose 3, 0, 3, 6, then 9, 12. And in another 8-point chip, we need to choose 1, 4, 7, 10 like this. In another 8-point chip, how we will choose the numbers or sequences? That is 2, 5, then 8, 11 like this, right? For this question. So that's why here we have taken 3 DFT which must be added together in order to make 24-point DFT. So in the first sequence FFT chip we will take n is equal to 0, 3, 6 till 21 y of n wn kn. This is a basic equation of DFT. Already we know that. And in the another 8-point chip we will take n is equal to 1, 4, 7, 11, 1, 4, 7, 10 till 22 y of n wn kn. In another 8-point chip we will take n is equal to 2, 5, 8, 11 till 23 in order to cover the 24 point. So y of n wn kn. So already we know that there's the 24 must be 8 into 8 into 8, right? So 3i plus 1, 3i plus 2 we have taken like this in this sequence. So just in the first summation we will vary I is equal to 0 to 7 because we have to take 8 points, so 0 to 7. Y is equal to 3i wn by 3 ki, or we can write 3i here, right? Okay, we will solve from here. So it is written as, if we vary from I is equal to 0 to 7, y 3i, right? W 3ki it will be, because here n is replaced by 3i, right? Here n. So if we take that 3 in the denominator, so it will be the written like this: y is equal to y in brackets 3i wn by 3 ki, right? Similarly, it is that this part is written as, it is already written, so I am solving this part only. Okay, here. So wn k, and that n is replaced by 3i plus 1, right? So wn 3ki plus multiplied by wn 3, sorry, k only, 3i multiplied by 3ki, and in 1 multiplied by only k. Okay, and if we take that n, that 3 in this by 3, then this will we get, right? And similarly, for other 8 point FFT, I varies 0 to 7, 3i plus 2, right? This can be written as like this. Similarly, it is also we will get like this only W n, that is k 3i plus 2. If we multiply this, then we will get this part, and already we know that this is even, and in the similarly we have divided in the even and odd sequence. Here we are dividing in three parts, so this represented as a y1k, this term, the 3, and this represented as y2k, let's assume that, and the extra factor will be multiplied in y2k. Similarly, in this sequence also, wn2k y3 of k, because this the third sequence DFT is represented y3k, right? So where already I have told y1 and y2, y3k represents the 8 point DFT of subsequences, right? So the designer can we take this solution to compute the 24 point DFT if he has available only 8 point FFT. So it will be y1k plus wnk y2k plus wn2k y3k, right? Have you got this question, or should I explain once? Okay, if you understand, so we can move to the next question. Okay, so moving to the next question. Using the ITFFT, compute DFT of x of n is equal to cos n pi by 4, where n varies 0 to 7. So it is a DIT, decimating in time. So here input must be in the bit reversing order and output is in the order. So it is here the total number of sequences is n varies 0 to 7, that is 8, right? So n is equal, total number of samples is 8, and x of n is given cos n pi by 4, where n varies 0 to 7. So in order to find out the sequence series with vary n 0 to 7, if we put n is equal to 0, then we will get cos 0 is, what will be the value of cos 0? Is 1. Yeah, someone is born. Okay, okay. Then first we need to find out this sequence by putting n is equal to 0, 1, 2, 3, 4, 5, 6, 7. So let's take one slide so that we can solve there. X of n is equal to cos n pi by 2, right? No, n pi by 4. N pi by 4, where n is equal to 0, 1, 2 till 7. And x of n we will get by putting these values of n. So first, if we put n is equal to 0, then we will get cos 0, then cos n is equal to 1, then pi by 4, right? Please calculate the values of cos 0, cos pi by 4, cos 2 pi by 4 if we are putting 2. Similarly, cos 3 pi by 4, cos 4 pi by 4, cos 5 pi by 4, and cos 6 and pi by 4, cos 7 pi by 4. Okay, then x of n we will get cos 0 is 1. If you solve cos pi by 4, you will get 0.707, right? Then cos 2 pi by 4, that is cos pi by 2. What is the value of cos pi by 2? 0. Then cos 3 pi by 4, we will get minus 0.707. Then cos 4 pi by 4, that is a cos pi. What is the value of cos pi or cos 180? That is minus 1. Then cos pi by 4, 5 pi by 4. 5 pi by 4 you will get 0. Minus 0.707. Then cos 6 pi by 4, that will be the 0. And cos 7 pi by 4 will be 0.707. So this is the x of n. Okay, if you solve this, first get the x of n, then divide into even and odd part, then apply in the butterfly diagram, right? So in the butterfly diagram, already we know x of 0 we have computed, that is 1. I am writing here, okay? So because we need to otherwise make a butterfly diagram, for that I have taken this one already. So x of 0 is 1. And what is the x of 4? Can anyone tell me? That is minus 1. What is the x of 2? That is 0. What is the x of 6? Already we have taken that sequence. From here we can write it here also. 0.707, then 0 minus 0.707, then minus 1 minus 0.707, then 0, then 0.707. It is easy to write here. So 1 minus 1, 0, then x of 6 is 0, then x of 1 is 0.707, 0.707, and x of 5, that is 0 minus 0.707. And what is x of 3? That is minus 0.707, 707. And what is the last one? X of 7, that is also 0.707. So now what we need to do, this row represents multiplication, and from here it is the addition, right? This represents the addition. So first compute the first line. Okay, so here 1 and w, we also need to compute what is a w8. It is 8.dft. So here multiplication wn, right? 0 or 1, 2, it depends number of stages. Okay, here the phase factor is given. So here we need to compute W80. What is the value of W80? It will be the 1. Okay, if you compute e to the power minus j 2 pi by 8, and here it is 0, so multiply e to the power minus j0 is 1, right? Okay, so it will be the 1 only also. So 1, and here it is going minus 1 multiplied by 1. So 1 minus 1, here it will, if you add, then you will get 0, right? And here it is 1 is coming in this row, and here minus 1 and minus 1. Minus 1 minus 1 is plus 1. So 1 plus 1 will be the 2, right? Here it will be the written 2. Okay, similarly we have to do here 0 and 0 is there, so we will get 0 only. 0 is 0 multiplied by 1, 0, and here also 0 multiplied by minus 1 and 0, and 0. Similarly we have to compute in this, for this line also 0.707, it is 1, w 080 is 1, so 0.70 and 1 multiplied minus 0.707. So 0.707 minus, it will come 0, right? Similarly, in this line, that you will get that 0.707, and then minus 1 and minus 0.707 will be the plus 1. 0.707, then you will get 0.707 plus 0.707. You will get 1.414, right? Similarly, here it is a minus, it is a plus, it will get 0, and here minus and minus 0.707 minus 0.7, you will get minus 1.414. Okay. Okay, so this is a first stage computation. Similarly, in the next stage, what we have to make here, we may need to make a butterfly of two rows. So first, then this will come multiply and add with this row, and this second row multiplied and add with the fourth row, right? And here the phase factor will be the 2, W80 and W82, because this is second stage, so these phase factor must be multiplied and then added. Okay, so for next stage computation, what we will get here, we have 0, right? In this 0, and W80 already we have computed, it will come 1 only. So what is the value of it? In this 0 will be multiplied by 1, so 0, and it is already 0, so here 0 plus 0 will come 0 only, right? Are you getting this question? Or okay, then okay, here in this line already we have 2, right? Here we have computed in this, here it is 2, right? And here now we have to compute this phase factor W82. So I am removing this part because already this has been completed here. So now we need to compute W82, right? So e to the power minus j 2 pi by 8 multiplied by 2. So e to the power minus j pi by 2, right? What is the value of e to the power minus j pi by 2? That is 2 will be there, or 1. I think 1 will be there. Okay, compute e to the power minus j pi by 2. What will be the value of that? Minus j, right? Okay, then this is equal to minus j, and here it is coming to 0. So 0 minus j. 0 will be there, so 2. Here 2 is coming, 2. Okay, in the next, what will be the 0? And from here it is also coming 0. Here it is a 0, so anything is multiplied in this with 0, it will come 0 only, right? And here it is also 0, so it will come 0. 0, right? No, 0 plus it is 2. So here will be the 2 only. Right? Now we have to compute this butterfly area in the second stage. So here it is 0 is coming now, and W80 is 1, but here it is 0. So 0 plus 0 is 0, and here 1.414, right? Here it is coming 1.414, and W8 is J minus J. It is came minus J, right? Yeah, it is calculating minus J will be there. So 1 point, if you add minus J, if minus J multiplied by this, so it will be J 1.414. So 1.414 plus J 1.414, right? It will come. Now here in this third row, in the second stage, 0 plus J 1.414. So J 1.414 it will come. Okay, and in this, so it is coming minus J. So minus J and minus 1.414. Then it is multiplied by minus 1. So it will come 1.414 minus J 1.414, right? But here 0 and 0, it will be 0 only, because anything is multiplied by will be 0 only. Okay, have you got the second stage calculation? You got this. Then next move to the third stage calculation. Here it in this the butterfly diagram is make the all the points. So in this phase factor, here the multiplied first in this, then added in these rows. So here W80, W81, W82, W83, right? So here first in this the value is 0. So 0 plus whatever value of this row plus multiplied by this phase factor. 0 plus 0, whatever W80 is 1, but multiplied by 0, so that it is 0 only. 0 plus 0 will be the 0 only. So x of 0 will be 0 we will get, right? Move to the next. Here it is coming to, and in the next, here W81. So already we have solved what is the value of W81. Where is we didn't solve. Okay, W81, what we will get? E to the power minus j 2 pi by 8. Here it is 1 only, so e to the power minus j pi by 4. What is the value of e to the power minus j pi by 4? Here we will get cos pi by 4 minus j pi by 4. So 1 by root 2 minus j 1 by root 2. Right? Okay. So W81 value is 1 by root 2 minus j 1 by root 2. That is 1.414 only. So 2 multiplied by this value and this value. This multiplied by this phase factor W81. What you will get? 1 by root 2 minus j 1 by root 2. Similarly 1 by root 2 minus j plus j 1 by root 2. What you will get? And add 2. So let's see, 1 by root 2 minus j 1 by root 2, 1 by root 2 by 2, 2 plus j. That will come, I think, 0. Here you will get, I think, 2, or can anyone verify it? 2 in this multiplied. So 1 by root 2 plus j 1 by root 2 and 1 by root 2 minus j 1 by root 2. So that will be the, I think, 1 by 2, 1 by 2, 1. So here we will get 3. 2 plus 1, 3. Right? Similarly, we have to calculate this third row, 0, and that will be multiplied by this 0 plus W82. W82 already we have find out minus G. So what is the whatever value is there, it will be the multiplied by this base factor, then added to this line. 0 plus 0 will be the 0 only. Next, this row, then multiplied by this factor W83, and then added to this row. So we didn't find out W83. What is the value of W83? E to the power minus j 2 pi by 8 multiplied by 3. So 3 pi by 4. What will be the value? So here we will get minus 1 by root 2 minus j 1 by root 2. Okay. E to the power minus j 3 pi by 4 value 1 minus 1 by root 2 minus j 1 by root 2. You can find it out also by yourself. Now calculation will be become tougher. So 2 plus multiplied by this factor. Okay. Then what you will get? 2 plus this will multiplied by, just I need to read out where, but so here we are getting 1 by root 2 minus j 1 by root 2, that is multiplied by minus 1 by root 2 minus j 1 by root 2, right? Minus 1 by 2. Minus 1 we will get. So minus 1. After multiplication of these two, minus 1. 1 will be there. Yeah. You can calculate it. Answer can vary also. So now x, we need to calculate x of 4. So x, this line it is 0, 0, and it is added and 0 this multiplied by W80, that is 1, 1 and 0, 0, 0 plus 0, 0 only. Now x of 5. So here it is a 1.414 plus j 1.414 multiplied by this base factor. Then add with 2. So 2 plus 1, I think 3. 3 will be there, hopefully. Now similarly you have to calculate x of 6 and x of 7. Okay. So x of 6 is 0, 0 here, and 1.414 this, that is 0 plus 0, 0 will be there, it is 0. So anything multiplied with 0, so 0 plus 0, 0, and x of 7 similarly 2 plus, it has came that multiplication plus 1 because it is had came 1 minus multiplied by minus 1, then 3. Okay. So how we can solve this question? This is solved like this. Okay, so maybe there is some calculation mistake will be there. So you can solve it like this. First, we need to find out x of n sequence. Then apply in the bit reversal order here. Then multiplied by the phase factor and add in the first stage, similarly in the second stage and third stage. Okay. Okay. So can we move to the next question? Have you understand this question, how to solve this butterfly diagram? I hope all of you have understand. Okay. Moving to the next question. This is also the DIF butterfly diagram. There is compute 8 point. The next question is compute the 8-point DFT of the sequences given x of n is equal to 2 and 1, 2, 1, 1, 2, 1, 2 using radix to DIF FFT algorithm. Here it is a already sequence is given, so it is a DIF, so it is a bit the sequence is in the same order and output is in the bit reversal order. Okay, and it is also the exact opposite to the DIT algorithm. So in this, we directly connecting these 4 to n by 2 point to n by 2 point, then we are dividing n by 4, then n by 8, like this. Okay, so in the bit reversing order already it is given, so directly it is x of 0. So 2, 1, 2, 1, then 1, 2, 1, 2, because it is starting from here, it is a 0, then 1, so x of 0 is 2, x of 1 is 1, x of 2 is 2, x of 3 is 1, x of 4 is 1, x of 2 is x of 5 is 2, x of 6 is 1, and x of 7 is 2. Now we need to calculate this. Let's calculate this in the first stage. So here it is directly multiplied and addition of this. So 2 plus this 1, add this one. So 2 plus 1 is 3, right? And x of 1 is 1, 1 plus 2, 3, 2 plus 1 is 3, and in 1 plus 2 is also 3. Okay, here we need to, in the first 4 sequence, we have to add, in the next sequence, we have to, we need to take difference of these. So here 2 minus 1, it is 1, because before that it is minus 1 is multiplied. Then here it is 1 minus 2 minus 1. Here 2 minus 1, 1. Then 1 minus 2 minus 1, right? So this is a first stage is computation. Now we have to compute Wn0, Wn1, Wn0, Wn1 in order to multiply in these sequences Wn1, Wn2 and Wn3. So here n is equal to 8. So W80 we have already seen in the previous. You can calculate it also again, but if you want you can calculate and put it in one place so that it is easier to calculate. W80 is 1. W81 is 1 by root 2 minus j 1 by root 2, right? W81, yeah. And W82 is minus j, and W83 is minus 1 by root 2 minus j 1 by root 2. Okay, so W80 is 1. So now first we need to calculate this. 1 is, so 3 plus 3, here directly we are just adding these two numbers because case factor will be added after this. 3 plus 3 is 6. Similarly 3 plus 3 6. Then here again 3, here minus is multiplied before adding, so 3 minus 3 will be 0, and similarly here 3 minus 3 will be 0, right? Similarly in this next 4 points, Wn0 is multiplied by, here it is 1, so 1 into 1 1, 1 plus W80 is minus j. So 1 multiplied by minus j. So minus j 1 minus j will be there, right? Similarly, in the next step here minus 1 and multiplied by minus j. Minus 1 multiplied by minus j. So here will be plus only. Minus 1 multiplied by minus j. So j plus W82. That W83 here will be W8123. Yeah. So minus 1 is multiplied. So W83 1 by root 2 it will come plus j 1 by root 2 here. So this will be added by this sequence. Minus that means minus 1 by root 2. Here minus is there, minus 1 by root 2 plus j 1 by root 2 and added with this one. So this will be cancelled. So j 1 by root 2 plus j 1 by root 2, that is 2j root 2. Then what we will get? Root 2j if we solve it. So here we will get root 2j, right? Similarly, we need to calculate here also. So w minus j. So minus j plus j plus j addition with 1. 1 plus j. And similarly, we need to calculate here also. What we will get? 1 plus j and that is minus 1 and multiplied by this one minus 1 by root 2. So it will come 1 by root 2 plus j 1 by root 2. Then multiply them. So minus 1 again minus, then minus 1. So it will be the minus 1 by root 2 plus j 1 by root 2. So I think again it will be cancelled. So root 2 j will be the answer. Root 2 j. Okay. Now we move to the next stage. Now we have to multiply by this W80 and W20 in this line in the last and the third and fourth line, then calculate this one. Okay, I'm removing from it here. From here you can calculate it also. This is somewhat tedious task. So now what we need to do, 6, it is coming 6 and plus 6 because there is no other. So 6 plus 6 here it will come directly 12 and the 6 minus 6 that will be 0. 0 is multiplied by this factor. After addition then we have to multiply by the phase factor. So it will come 0. Next we need to see here it is 0 multiplied by this phase factor. 0 is anything multiplied by, so 0, and here it is also 0, so 0 0 plus 0 only, and similarly 0 and 0, so everything is 0 0. Now next need to what we need to 1 plus j, and here it is also coming 1 plus j. What is coming in this line? Root 2j. So how much it will come? Root 2j plus j, 1 plus root 2j. Okay. 1 plus, yeah. Now next 1 plus j minus root 2j multiplied by this phase factor, that is 1. So 1 minus root 2j, and similarly in this wn0, that is 1. So 1 plus j, and it is minus root 2j, I think. So 1 minus root 2j, and here also minus 1 minus j, 1 plus j minus root 2j multiplied by this, it is 1, so nothing will be there. So 1 plus j, 1 plus root 2j, right? I think this answer you will get. There is maybe some variation or calculation mistake will be there, so you can but you can compute like this. This is TIF, test mating in frequency FFT algorithm. This is with reversing order. So now after that we have to write in the correct order, right? So x of k will be, that is x of 0, 12, then 1, 1 plus root 2j, then 2, that is 0, then 3 we have to write, that is 1 minus root 2j, then x of 4, that is 0, then x of 5, 1 minus root 2j, something like that. So we have to write in the order. Okay, have you got this? How to solve that DIT FFT and DIF FFT algorithm? In the DIT, we have seen that we first multiplied by phase factor, then addition, and in the DIF, first we have to add and subtract, then multiplied by the phase factor. Just remember this point. Okay. Okay. So now moving to the next question. Okay. So next question is, if W1664 is equal to W128x, find out the value of x. So what will be the value of x? Options are A 16, option B is 64, option C is 32, and option D is 128. So let's see how we can solve this question. It is given that W64 16 is equal to W128x, right? Already we know that Wn2k is equal to Wn by 2k. Already we know that, so just we need to apply this into this. So how we can write this in terms of 64, this? So W128 divided by 2 into x, right? In order to get this 64, first we need to maintain this n, because n number of samples are available everywhere. So what we need to do, then it is divided, so it will go up to x is equal to 128, right? Now how we can maintain this in this, if we get, so if we multiply by 2 in this, then we will get 128 and 32, right? Then now it will be the same, so 2x is equal to 32, or we can take any constant k. So k is x is equal to 2k, then x must be 32. It must be or 32. Okay, if we multiply with 2x. So the option C is the correct answer. Okay, in order to just make sure that it must be equal the value of n. So x is 32, then it will be the equal only. X is equal to 16, 2. Okay, right? So got this question? How we can solve this? What is W? Just remember this. W 16, it is 16, 64, 68. So if we want to equal to this W 128 x, this, so we must be multiplied by the factor 2. Then we are able to equal this factor 128, 16, 64 into 2. And similarly, we have to multiply in this one 32. Now it is x is equal to 32, right? Yeah. Okay. Okay. So moving to the next question. So calculate percentage of saving through Radix to FFT algorithm of DFT coefficients, assuming n is equal to 5, 1, 2. So here n is given 5, 1, 2. So number of complex multiplication in Radix to FFT algorithm is how much? That is n by 2 log base to n. Already we know that complex multiplication in FFT complex multiplication. So n is given 512, 512 divided by 2 log base 2512. So that will come 256 log 2 to the power 9, and that will come 9 multiplied by 256. How much we will get? 9 multiplied by 256, that is 2304. You can calculate this. Okay, so calculate percentage of saving through Radix to FFT algorithm of DFT coefficient. So from where we have to get that. So number of multiplication required for DFT, we need to also calculate the number of multiplication required for in the DFT in order to get percentage of saving in FFT algorithm. So number of multiplication in DFT, how much? It is n square multiplication required. So 5, 1, 2 multiplied by 5, 1, 2. So how much it will, you can get it? How much will be 5, 1, 2 multiplied by 5, 1, 2? That is 2, 6, 2, 1, 4, 4. You can calculate in the calculator also. So how we calculate the percentage of saving in the FFT corresponding to DFT algorithm? So percentage of saving we will get total number of multiplication in DFT, that is 262,144 divided by total number of multiplication in FFT required, that is 2304, right? Percentage saving in order to get percentage saving. Then if you divide this, you will get 113.8. Just calculate this. So correct option will be the C, 113.8. In order to get percentage of calculate the percentage saving through Radix to FFT algorithm of the FT coefficient, just you need to calculate number of multiplications are required in FFT algorithm. and number of multiplication required in DFT, then the number of multiplication required in DFT divided by number of multiplication required in FFT, then you will get the number. Okay, you can, yeah, yeah, you can take that one also. Okay, number of multiplication, number of additions, number in the saving. But here we have calculated in the options, we have taken from that only. You can calculate from addition also. Mm. As the option. Yeah, yeah, as the or additions. You have to check. I am directly telling you, but you have to choose. But in the examination, you have to check in both number of complex addition required in DFT and number of complex addition required in LFT. Then take a percentage saving. Then they see whether the options are matching or not. Then based on that, select the correct options. Okay. Okay. So have you understand this question? Can we move to the next question? Yeah. Okay. So moving to the next question. If x of k is the n by 2 point DFT of a sequence x of n, then what is the value of x k n plus n by 2? Option A is f1k plus f2k. Option B is f1k minus wnk f2k. Option C is f1k plus wnk f2k. Then none of the mentioned. So already we have solved this question. If we can solve it again, already we know that the sequence x of n is divided into 2n by 2 points. One is a even sequence, one in the odd sequence. On already we know that x of k is follow the periodicity property. So x of k must be equal to the mass x of k n by 2, or f1k must be equal to f1 k plus n by 2. Similarly for f2 k, f2 k k n plus 1. But we have seen that in the odd part there is a one extra factor, that is wnk, right? Because that is x to in the odd part to m plus 1, so that one part adding the other phase factor. So this phase factor will be the, if that is in the periodicity property, if we add in this phase factor n by 2, then we will get wnk multiplied by wn n by 2, and this value is 1, so it will be adding wnk, okay, in order to follow the periodicity property. So here we will get f1k minus wnk f2k. Okay, so the correct option will be B only. If x of k is the n by 2 point DFT of sequence x of n, then what is the value of xk plus n by 2? So always remember this. If it is k plus n by 2, in the periodicity property, f1k and f2k is equal to f2 k plus n by 2, but in the odd part, that must be added k and k plus n by 2 also, and this is the minus 1. So option B is the correct answer. Okay. Okay. So moving to the next question. Okay. Consider a 6-point decimation in time fast Fourier transform algorithm, for which the signal flow graph corresponding to x of 1 is shown in the figure. In this figure, let W6 is equal to e to the power minus a 2 pi by 6. In the figure 1, what should be the value of coefficient a1, a2, a1, a2 and a3 in terms of w6 so that x1 is obtained correctly. Here it is given the 6 point dit dft, so n is equal to 6 is given. So it is a DIT algorithm. So input is in the bit reversal order, right? And already we have seen the butterfly diagram. This is addition of these two numbers in the first stage. The 6.8 is only two stages are there, 1 and 2. So what we will get of A1, so x of 0, here what we will get, x of 0 minus x of 3, right? And then multiplied by A1. First we need to see this line, and from here how we will calculate this, x of 1 then minus x of 4 multiplied by minus x of 4 then multiplied by a2, right? And similarly in this line what we will get, x of 2 minus x of 5 then multiplied by a3. So what are the values of a1, a2 and a3? We have already seen that in the butterfly diagram. In the first we have to multiply it by w and 0. In the next stage we have to multiply it by w and 0, then w and 1, depends on number of stages. We have to divide it. So here what we have to take, w and is 6 is already given, so w6 0, what will be the value of w6 0 is 1. In the next stage w6 1 we have to multiply. So what we will get, just we need to calculate this one, then w6 that is 2, right? In the next stage in the butterfly diagram we have to see that how we are multiplying by the phase factor. In the first stage we have to multiply by w and 0, then in the next stage we have to multiply by w and 0 and w and 2 depending on number of lines. Then in the next stage we have to multiply by the phase factor w and 0, w and 1, w and 2, w and 3. So here only 6 points are there, so depend on that we have to multiply. So what will be the a1, a2 and a3? So in 8 a1 w60 is 1, so a1 must be equal to 1, and then in the next step the phase factor must be w6 1, and in the next is w6 2. So that option C must be a correct answer. A1 is equal to 1, A2 is equal to W6 1 and A3 is equal to W6 2. Okay. So in order to get x of 1, that all these components must be added with multiplied phase factor. So expected phase factor must be this one, right? Okay, so shall we move to the next question? Have you got this question or you want to? Okay, great. Okay, moving to the next question. Okay, if n is equal to Lm, already we have seen the divide and conquer approach, n is equal to L into m. Then what is the value of W, N, M, Q, L? So if you have gone through the divide and conquer that formula where we have to take either row wise or column wise, that is one of them. So then what will be the value of Wn MQL? So this part we can write like this. We are taking row wise or column wise. MQ n divided by L. If we take that L in this denominator. Okay. So already we know that n is equal to Lm. So what will be the value of n by L is equal to m. So is this can be written as Wm MQ, right? Have you got this? How we can write this? I can clearly write it. We know that n is equal to Lm. So n by L is equal to m, right? And here it is given what is the value of Wn M Q L. So Wn by L, we can write it if we take the L in the denominator, M into Q, and N by L is equal to M, so it can be written as Wm M Q, right? So now we see the which option it is matching. So option A, it is matching with the option A. So option A is the correct answer. Okay. These type of problem we have to first see the question, then see the options, how we can solve it. Sometimes it is not, it is looking like difficult, but it is not that much of difficult. Just go through the options and check, then solve the questions. Okay. Okay, so moving to the next question. Sirisa, I think this question is you are asking for in the last class. Okay, okay. Yeah, so it is the question is the STFT analysis was computed for 3-second long speed signal. So we need to calculate STFT for a 3-second speed signal. The speed sequence could be anything like this. For a, it is calculated for 3 seconds. And using 25 millisecond Hamming window, we have to take a Hamming window for 25 milliseconds, right? Anyway, we have to just move and calculate them. With time decimation rate 20% of the window length. For that window length, the decimating factor is 20%. So now we have to calculate 25 milliseconds, 20%. So 25 milliseconds of 20%, what will you get? 5 millisecond to 25 millisecond minus 5 millisecond will be the 20 millisecond, right? Now the length of the window, Hamming window is 20 millisecond because the length of the Hamming window is decimating by 20%, right? If each of the window is considered as an analysis frame, determine the frame rate. So how we will get frame rate? Here it is time is given, na? So in order to get the frame rate or F or L, you can represent it any, then we have to reverse it that time, then we will get the frame rate in the second. So it is 20 milliseconds, so 1 by 20 millisecond, or you can write it 1 by 20 into 10 to the power minus 3 seconds, right? Now if you take, right, you can calculate like per second, frame per second. Now it is frame per second. So how much it will come? 50, right? So 50 frames per second, right? Have you got this question, Sirisha? How you have to calculate it? Actually, this topic will be covered later in the decimation class. That is, I think in week 10 or something. But this question, I think, by mistakenly, technically last time has given, or they maybe they have. So the decimation rate and that other factor will be there. Will be the like in the next class, but it is solving like this. If there is any signal is given and the window length is given, first we have to take that window length, but here we are decimating the window length by 20%. So first we have to calculate that the factor of decimation. Okay, that is 5 millisecond, then minus it, calculate the total number of now window length, then take a frame rate. Okay, so option A is the correct answer, 50 frames per second. Okay, okay, I hope all of you. So for this week, the simple example. Okay, 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 okay. I will try to include that question in the next class. Let's see. Okay. Yeah. Okay. So for this week, the questions have been now set of questions has been completed. So thank you everyone for joining. If you have any doubt, you can ask now, or if you don't have now, we can close the session. So guys, you have any doubt, please ask in the chat box. Okay. For other person, if you anyone want, ask any question. Otherwise, we can leave the session or we can close the discussion. The question has been completed. Okay, nobody has any question. Okay, thank you everyone. Thank you for joining.